Hello and welcome to my screencast about Service Fabric. This is the first part in a series of screencasts that will focus on Service Fabric application development. Service Fabric is a big subject, and I felt like it's better to break the screencast in different parts to make it easier to follow along. In this first part, we will explore Service Fabric from a theoretical perspective and understand its programming model and use cases. We will also look at a basic demonstration of the Service Fabric runtime running on a local environment by developing a small application with Visual Studio 2017 just to get an understanding of Service Fabric application development. In the following screencasts of the series, we will enhance the basic application while exploring more Service Fabric programming concepts. Let's get started. Service Fabric is a distributed software systems platform that simplifies development, deployment, and management of microservices. It is typically used for large-scale complex applications that are expected to serve a large user base and are required to operate with significant speed and reliability. Service Fabric is used as a platform of choice for many popular Microsoft services such as Azure SQL Database, Azure Cosmos DB, Dynamics 365, Skype for Business, etc. This probably gives you a good idea about the operational complexity and performance specifications that Service Fabric-based applications can support. Service Fabric is Microsoft's microservices orchestrator and as such runs on a number of VMs or nodes running on VM clusters. The Service Fabric runtime is OS agnostic and able to run on either Windows or Linux machines located on any public cloud provider such as Azure, AWS, etc., and even on premises on your own servers or laptops. The Service Fabric runtime is deployed on multiple machines on a cluster, and it is responsible for managing the services distributed across the cluster. The range of nodes can vary depending on the scale the application requires, but at the very minimum, a 5-node cluster is required on Azure when running production applications. Each node will have multiple services running on it, all automatically managed by the runtime. Service Fabric will make sure that the minimum number of services are always up and running based on the configuration settings, and it will automatically distribute and redistribute services on different VMs to maintain the highest possible operational reliability. There are a few different options when it comes to developing applications running on Service Fabric. The approach that takes advantage of the full power of Service Fabric are reliable services, and this is what this series of screencasts will focus on. Reliable services are fully integrated with Service Fabric and therefore have access to the Service Fabric programming APIs that provide capabilities to query the system, monitor health of services running on the cluster, receive code change notifications, discover and communicate with other services through well-defined protocols, use reliable collections, and other benefits. There are some variations of reliable services. One option is to create stateless services. Those are services that have no state integrated within. Service Fabric does not maintain their underlying data either because there is no need of them or because those are stored on external databases such as relational databases, queues, blobs, etc. Examples of reliable stateless services are web APIs or services that perform some calculations. Another option is to use stateful services. Those are services that maintain their own state locally. Data are persisted across service calls and are always available through multiple replicas that Service Fabric automatically creates, synchronizes, and maintains. Storing data on the local disk provides better data querying performance since there is no need for external calls to a database. Stateful services store their data in reliable collections based on the iReliable dictionary interface. It is important to note that while simple to use, as we will see, stateful services are quite different from the typical programming model used in most cases, and as such, you should fully understand them before using them. A third option of reliable services are stateful actor services. Actors are based on the actor programming pattern of computer science. An actor is a single-threaded, isolated, and independent unit of compute and state. The actor pattern is a computational model for distributed systems in which a large number of actors can execute simultaneously and independently of each other. Actors can communicate with each other and they can create more actors. Reliable actor services are typically used in systems that require a large number, thousands or more, of small, independent, and isolated units of state and logic to run. Some examples of real-life systems are IoT systems monitoring thousands of devices and online computer games with thousands of user sessions. Other than reliable services, Service Fabric also supports guest executables and containers. These implementations are outside of the scope of this screencast. Our primary goals for this first part of the Azure Service Fabric screencast are to demonstrate how to develop and run a Service Fabric application locally and explore the Service Fabric Local Cluster Manager dashboard. To be able to develop and run a Service Fabric application, you need to enable the Service Fabric tools, which are part of the Azure development workload in Visual Studio 2017. In addition, you also need to install the Microsoft Azure Service Fabric SDK and Runtime using the Web Platform installer.
Okay, let's have a quick walkthrough of the tools installation. Look for Visual Studio installer on your computer and open it. Under the Visual Studio installation, select the Modify option, and then click under individual components and look for the Service Fabric tools. Make sure if the checkbox is not selected to select it, and then click Modify. I will exit this because I already have it installed. Next, we need to install the Azure Service Fabric SDK, and in order to do that, we need to use the Web Platform installer. In a browser window, we navigate to the appropriate URL and we install the extension. Once we have it installed, we can open it and look for the SDK. Make sure that you select the Microsoft Service Fabric SDK without the tools, since the tools version is for an older version of Visual Studio. Click Add and then Install, and I will exit again since I have the SDK installed. Now let's check if we have everything we need by examining Visual Studio. Make sure that you always run Visual Studio as an administrator because you need elevated permissions to run Service Fabric applications. Under File, New Project, select the Cloud category and you will see an option to create a Service Fabric application. This indicates that you have the appropriate tools to get started with Service Fabric.
One of the things that we get when installing the Service Fabric SDK is the Service Fabric Local Cluster Manager. Typically, this starts by default when you start Windows, but I have disabled it because I do not like running programs that I do not always need. I'm going to search for it and open it. As soon as it starts running, we can see an icon in the system tray. Right-click over the icon and select Manage Local Cluster. This will open Service Fabric Explorer on a browser window. Service Fabric Explorer is where we can visualize important aspects of the cluster. Right away, we can see information such as the number of applications that are running on the cluster and how many nodes there are. Currently, we're running 5 nodes and we have 0 applications. On the left-hand side, we can expand and view information about applications, nodes, and some Service Fabric runtime services that are installed and running by default. These services are necessary for the Service Fabric to run properly, and they handle things like DNS resolution for service communication, failover management, cluster management, etc. Let's expand the Cluster Manager service and the DNS service. The Cluster Manager service is a stateful service with one partition. Being a stateful service, Service Fabric has distributed it in 3 nodes. 1 is the primary and 2 are secondary active replicas. If the primary node fails, one of the secondary nodes will take over and become primary, and our Cluster Manager service will always be available. It is important to note that the state or data that a stateful service maintains is replicated across all nodes. Hence, we have the term replica. When we deal with stateful services, we work with replicas. Now let's expand the DNS service. This service runs on one partition, but it is running on one node. If we look closer in the details, we will see that we do not see replicas, and instead we see instances. The DNS service is a stateless service, and stateless services do not have replicas. This particular service has only one instance running. We will talk more about partitions, replicas, and instances in a future clip. In the Details tab, we can see more detailed information about the cluster. Under Cluster Map, we can see how the nodes are distributed across different update and fault domains. This is important for when we are actually running on Azure with actual multiple nodes. Locally, we are running only on one node, and this is just a simulation of how things would look like in a production environment. We can also see metrics about the cluster and the cluster manifest. For now, the most important information we get is that we are running a simulated 5-node cluster and all the system services are healthy without any warnings and errors. One important tip I can give you here is that sometimes on the local host, the DNS service indicates an error. If you get that error, it will show up here on the dashboard. To fix this, all you need to do is go to your machine services and locate internet connection sharing. Stop this particular service and reset your cluster through the system tray icon. Now let me get out of here and show you one more thing. Right-clicking on the cluster manager icon, we can see how we can switch the number of nodes from 5 to 1 and vice versa. Running on 5 nodes is good to simulate a production environment, but it slows down development. So a general guideline is to develop using one node and when ready, test locally on a 5-node simulation to make sure things run smoothly before deploying. In a 1-node cluster, we can run the refresh application debug mode, which allows us to make changes to our service projects and see the updates live without having to redeploy or upgrade the entire application. I will demonstrate this in the following clips.
Now that we have the necessary tools installed, we are ready to create our Service Fabric solution. Let's open Visual Studio and remember to always use administrator privileges. We will select Service Fabric application under the Cloud category and browse for the location that we want the project to be in. The next screen shows us all the types of projects we can use with Service Fabric. As we can see, we have different flavors of stateful, stateless, and actor service type of projects that we can select. There is support for both .NET and .NET Core, and we can even see options for guest executables and containers. For our entry point project, I will select an ASP.NET Core stateless service. As a template, I will choose a web application MVC template. Once that is created, I will compile the project and make sure everything builds. We can see that we have two projects in our solution. One is the Service Fabric project and the other the web application we selected as part of the solution creation. The Service Fabric project is a project that contains important configuration and metadata information about all the other reliable services in our solution. For now, we have only one reliable stateless service, which is a web application. Service Fabric uses this project to create an application package, which among other things contains a very important application manifest. If we examine the application manifest, we will see that under the default services element, the web application is described as a stateless service of a specific type, which in this case is a Service Fabric demo.web type. We can also see the instance count pointing to a specific parameter. And as expected, since this is a stateless service without any state or data, it operates under a single partition. Under application parameters, we have three different files. One for the cloud, one for the local 1-node cluster, and one for a local 5-node cluster. These files contain configuration information targeting specific environments. We will take a look at the local 5-node cluster file. We can see the parameter that specifies the instance count for the web application that we saw being referenced in the manifest. As expected, the instance count is set to 1. We can change this value to a number between 1 and 5, since we can run from 1 to 5 nodes locally. Under scripts, we can see a PowerShell script that runs when we deploy the application to the cloud. Now let's look at the ASP.NET Core Web Application project. This project is slightly different than a usual ASP.NET Core project because it needs to communicate and operate under the Service Fabric runtime. In order to do that, there are additional NuGet packages that are installed as part of this project. Now let me remind you that you could deploy an ASP.NET Core application as a guest executable and not as a reliable service, and in that case you would not need to use the Service Fabric APIs. But that, in my opinion, kind of beats the purpose of using Service Fabric. Let's take a look at the service manifest of the web application. We can see the service type definition and also the endpoint definition. Here we can define the protocol, which by default is set to HTTP, and the port number. Right now our service is listening for requests on port 8334. We can modify these values as needed. When we examine web.cs, we will see that this is code that typically exists in the program.cs file of an ASP.NET Core application. Instead, in an ASP.NET Core Web stateless reliable service, this code is handled in the web.cs file. This is a class that inherits from stateless service and overrides the create service instance listeners method. This method is invoked by the runtime when the service is ready to accept requests. As you can see, this method returns an IEnumerable, which means that we can have multiple listeners listening on different ports and different protocols. The listener contains a web host builder that returns a Kestrel web server with the appropriate context and setup defined here. Notice the usage of Service Event Source, which is a class created by default and provides logging capabilities. Startup.cs contains the OWN middleware code that configures the HTTP request pipeline. In program.cs, we will see the usual main method, but in this case the code we would expect to see here is actually in the web.cs file that we examined earlier. In a stateless reliable ASP.NET Core web application, the main method is used to register the service and create an instance of the web class. Right after the service registration, we see again usage of the Service Event Source class for logging, and then code that basically tells the service to keep running forever. Finally, the Service Event Source class contains the code that provides logging capabilities. This is very important for a distributed application in order to be able to diagnose possible problems. Before we run the application, I will examine the local service cluster manager. As we can see, we are still running on 5 nodes and we have 0 applications. We're about to change this. I will run the application without debugging. A browser window opens and we can see our web application running and displaying the default look and feel that came with the template that we chose. Now if we look at the cluster manager again, we can see that we have one application indicated. We can see the application type and the name of the stateless service. This type of naming convention for the name is followed for all services, and by this name we establish inter-service communication. If we drill down even more, we will see the partition and that it is running on node 2. And indeed, we can cross-reference this by looking under node 2 and seeing that our application is deployed there. Now let me remind you that nodes on the cloud are actual virtual machines. These VMs and the services running on them are managed and orchestrated automatically by Service Fabric. We only need to provide the configuration and Service Fabric handles everything else, ensuring availability, scalability, reliability, and fault tolerance. We have now finished part 1 of the Service Fabric screencast series.
In this part, we covered mostly the theory and some configuration of Service Fabric. In the next part, we will dive deeper into the Service Fabric reliable service programming model and demonstrate how reliable services communicate with each other. As always, please do not forget to subscribe to my channel by clicking the subscribe button at the bottom right of the screen and sign up to receive notifications when new videos are posted by clicking on the bell icon.